that's 120 no matter what. You know, transfer more or less. That there, that's pretty much even. Let's say that that's the 120. You have the pen scratcher, piece of crap shit you have here. Okay. That's the beauty about cement. You can use cement. Oh.
Timber.
So if that's 120,
that's about a foot difference.
right? And you say that the average floor to floor is how much?
I don't remember exactly.
133?
It's a little over 120. It's maybe 123 to 127. But I remember.
Is the average?
Yeah. But I could be wrong. But I'm pretty sure that's what.
Well, we're gonna need to know that average because if 123, that means you'd have to have the platform here.
Well, I mean, my next concern, like, what I noticed was, we don't have much space for cantilever.
There is no cantilever. It's a drop ladder.
No, but we're gonna need a platform, right?
Right.
Yeah, but we're gonna need supports.
Right.
So the supports, if we start here, then we only have from here down to there.
Right. They come down. They're gonna land on this stupid thing right there.
And so that's enough angle? Because I didn't really check. But it just seems like that one has more angle.
Well, that's another factor that's going to influence where it can be. Because beyond that, it can't be, right? So don't forget, you're making this piece fit. Now, you're going to have to make the supports that basically come out here. So if you have a standard mathematical support, here's two things that are going to affect what happens and what doesn't happen. If they come out 60 inches, boom, and they have a brace on them that's 72, for example, and the diagonal on it is 45 degrees. You can literally make a template of one using simple angle of this one, and you bring it here and you say it can only be here before I run out of where I can land it. You understand?
Yeah, but
that automatically gives you your mathematics of where you are, where you can be. Because the beauty about fire escapes is this. When you have no restrictions, man, 77777, and it is what it is, and it lands where it lands, and that's it. But every now and then, for you to become a good fire escape guy, especially on old buildings and you're retrofitting, you have to be a mathematical wizard. And the mathematical wizard is taking known points, circles, spaces of windows, known sizes, known I-beams, known things, and you document that all onto a computer, which we can do on this. What I'll do is I'll actually take all this information. I'm going to take all this information off of this, and I'm going to enter all that information into my laptop. And then on my laptop, I'm going to give the mathematical solution to this, including the fact that you have a ladder there or a staircase there that is already a fixed point. So between me putting my angles where I want them and this staircase that you stole off another place here, I have to see if I can move my platform in such a way that I meet the 7 and 7 or the 9 and 9 or whatever that stupid thing is going to be.
Yeah.
So I have known pieces that I'm going to try to use. Maybe I can extend it one more tread and satisfy. Maybe I won't. Maybe it'll have to go back where it belongs because I can use the railing, but the staircase should go back where it belongs because the new one will be utilized here better. And the new one, I can easily replicate the stairs, but I can't replicate the rail. So I'll keep the rail for down here, but I'll put the stairs back, and I'll put the staircase here because now I have 13 more inches I got to deal with. And only on this staircase will I do the mathematical difference. Meaning, I then choose that I have to put this a certain place, and that's it. I have no play on this mathematical problem.
To fit that.
And I'll play with the stair, even though all the other stairs are 9, 9, 9, and 9. This one has to be 8 and an eighth.
So what's the limit for something this old?
It doesn't matter. This is a pre-existing condition. You have no choice now. You understand? You can make anything you want to satisfy as close as you can to the existing condition. Because nobody's going to check it. You understand? It's a pre-existing condition. It's not brand new construction.
Okay.
You know what I'm saying?
But there's
So okay, now it's a drawing.
Yeah, well, I mean, what comes in my mind are two things when you say that. The first thing is, I understand the whole, if you could raise the whole thing, I mean, you could probably fit as close to that as possible.
Right.
So the next thing that comes to my mind is, Well, how much lower or higher from this ledge can we be?
You don't even have that choice.
So it doesn't matter.
No, it's not. You don't have that choice. Mathematics is going to tell you what you can and cannot do. You're just going to choose the best option for you. Because right now, you're not starting with a clean slate and you can do whatever you want to get to the ground. This is not a brand new fire escape. This is an existing condition with a mathematical piece missing, and you have to come up with a solution. That's why they're paying you the big bucks.
Okay.
That's all. So now, what do you got to do? You got to take the known information. You're going to say, okay, I have this limit that my I-beam. This is a beam, right?
Yeah, that's right.
So from here is all I have is from here up. So now I need to take mathematics. I need to draw mathematically. I need to draw this and show all the ins and outs and all this thing and how far out it comes and do all my math and go all the way to the next level. So I have to literally draw this fire escape to this next level, and then I have to see what the level above is and say, okay, the level above is 122. The problem down here is 144. Now that's my problem. Now I go to a computer and I sit there and I draw and I scratch and I end up with a solution.
Yeah,
You can draw it by hand, or you can draw it by computer. If you have a computer, great. If you don't have, you have to draw by hand. I always recommend that everybody draw by hand, because by drawing by hand using quarter-inch scale and little blocks of quarter-inch scale, you mathematically come up with a solution already drawn. So that's what I'm going to do here. I'm going to draw a cross section of this thing, and I'm going to see if I can come up with a solution, both an elevation and cross section of what it's going to take to get this thing to work. Okay. So you have paper. Who has paper? Is that a little notepad? Oh, you have your notepad, right?
Yeah.
So let's get your notepad over here and let's start drawing. Let's get this whole thing drawn. Did anybody ever get a measurement all the way to the ground?
All the way to the ground? No.
Okay. What I'm going to do is I'm going to measure to that I-beam with this piece of crap tape measure. This twisting spaghetti tape measure.
But it's not going to be long enough anyway.
This non-compliant tape measure.
To the bottom of that.
Come on, baby. She's like a girlfriend that just is not complying with the situation. Oh, you whore. Come on. You and that special silver box. That's at home. I don't know what you're doing at home. Oh man, this whore is just... She's toying with me. She's toying with me. There you go. Write this measurement down, please. 108. 108 to that I-beam. Okay? Alright, so let me do my math. Sorry. Okay, so got my I-beam. Got my bigger I-beam.